recording, and let me share my screen as well. Just a second. Okay, I hope that you can see my screen. So we're gonna continue our design patterns lab sessions. If you remember, we were talking about creational design patterns, right? So, and in the last lab, we talked about these three design patterns, and today we will talk about prototype and singleton. Okay, so let's start with prototype. So prototype is also creational design pattern and lets you copy existing objects and also without introducing another coupling on the classes, right? So for example, let's say you have an object, right? And you want to create an exact copy of it instead of referencing to the same object. How would you do it? So the simplest way could be you will create a new object of the same class, then you will iterate uh, over all the fields, right? For example, if it has, let's say, 10 properties, you have to assign the property of the old one to the new one, to the new instance, so that you could perform the copy or clone operation in that way. But we have some problems regarding this way. The first problem is that the properties or variables in your class might be private, right? So it means that you cannot access these properties from outside of the object, right? And also, as we said earlier, whenever you access the class properties, it means that you are now introducing another coupling. Basically, this is high coupling. So if we take a real world example, for example, if you follow the simplest approach, like these two guys tried to clone the airplane, right? But in the end, 1 month after, let's say, they had something, but not airplane, right? So you might have such problems if you follow simplest uh, approach. And the solution is the prototype design pattern, which means delegating the cloning or copying process to the object itself. So you will have a common interface for all the objects that support cloning, and this interface via interacting with this interface's method, such as copy or clone, whatever you will name it, you can just decrease coupling, and you will have another clone from the object itself, right? So if we look at the prototype pattern structure, we may have the following situation. For example, a client wants to have wants to clone some object, and you have prototype interface, right? Which that object which is about to be copy it will extend, or in Java language, implement this interface, right? Let's say concrete prototype. And in concrete prototype, when it's being cloned, you can assign its private fields, right? And you can also have multiple inheritance from the prototype interface, and multiple classes which are extending this interface in the same level, or in the same, let's say, vertical tree. They can access their private variables, and they can assign to the new object that is being cloned, right? So this is how you can implement prototype pattern. So I hope this is clear. It's very easy. It's one of the easiest patterns. So if you have questions, please interrupt me and ask your questions. Otherwise, we will go to the next design pattern, which is singleton. Singleton is also one of the simplest and easiest design patterns, and it's very popular. I hope most of you have worked with singleton. So singleton lets you ensure that a class has only one instance, and also you have to provide a global access to that instance, right? And so let's say you have the following situation. You have some shared resources such as database or file, right? In order to act, when you are accessing this shared resource, it's better to have one, let's say, controller class, or we can say that one class which will execute transactions, or read or file executions to this database or file, right? So it's better to have only one class, since if you have multiple classes reading and writing at the same time, you may have errors, conflicts, or another, let's say, unexpected situations. So by doing so, uh, by doing so, you uh, you have this you have the situation, and you need to have one instance, and it's better to it's you want to access the let's say class from anywhere of your within your project, right? So the solution could be singleton. Even from the structure, you can see that the singleton pattern is quite easy. Basically, it has one private method, sorry, constructor, which cannot be accessed from outside, right? So that you prevent creating new objects by others, and you also have a private field which is the type of singleton, and you have a get instance, usually static, which can be accessed from the class name. And here you will introduce, you will create your singleton object if this singleton object is not created yet, right? This is quite easy design pattern. However, we have several ways of implementing of this pattern. So in this session, let's talk about three different ways of implementing, and each one has its own strengths and, let's say, pitfalls. So the first approach is classic singleton. So uh, if you look at this singleton, it's very easy. So you will just, as we saw in the structure of the singleton, you will only have one private constructor which cannot be accessed from outside, right? And you will have uh, private field whose type is singleton, right? And your main method is get instance. By this get instance, first of all, you get the object of your singleton, and you can also, let's say, implement the logic of singleton. That is, if object is null, you will create. Otherwise, you can return the existing object, right? So this is the classic singleton, but we have some problems regarding this approach, especially if our system or project supports multi-threading, since let's say, especially in get instance method, if two or if more than one thread access get instance in the beginning, you may have problems with having more than one singleton object, right? I had the situation where I have just declared my singleton class in this way, and in my multi-threading application, it was Android application, I had a problem where my singleton class, I had more than one singleton instances. It was very difficult to find out that the problem was that singleton classes was being created more than once. So it's very hard to uh, even debug. I found out by logging uh, that my singleton class was instantiated more than once. So uh, if two threads access get instance at the same time, you will have two singleton instances. So you see, so this approach is not for multi-threading. So if you have multi-threading, you can try the second approach, which is in Java. We can say that synchronized singleton. So here we have a synchronized keyword here, right, in the method. So it is the same approach, but we have introduced synchronized. And here we know that whenever we need, let's say, whenever two or more than one thread access this get instance, they will wait each other, right? So that you make sure that this you will have only one instance of singleton. But we have still problems with this approach, even though we made sure that now we have only one instance of singleton. Okay, why? How? Whenever you mark a method as synchronized, this means that other threads should wait a particular should wait the thread before it was executed to finish this method or to exit from this method, right? So if, let's say, if this method get instance is is being accessed by three methods at the same time, it means that you will lose multi-threading advancements, ad advantages, right? I mean, if you want to provide some, if you want to have the advantages of multi-threading, such as, I don't know, finishing the tasks and dividing the tasks into several threads and solving the problems, you will lose this ability, since get instance method makes your threads to be executed in a sequence way. So this is a problem, and it will make your project, or it will make your system slow. And this is, we can say that this is an expensive solution if we want to support multi-threading and have only one instance of singleton. And the next solution could be um, instant instantiating singleton object when the class is loaded, right? So if we uh, mark singleton object, singleton property as static, as we saw here, right? So this means that this singleton object is created or instantiated whenever singleton is loaded into GVM, right? So by doing so, we make sure that our singleton is uh, only instantiated only once, and no matter what, even if um, your project or system supports multi-threading, now you can uh, you may not worry, you don't have to worry about git instance method, right? So even if two or more than one method access get instance, they will use the same object, since you are not have if operator, which makes the problem, right? So this is called eager instantiation. But still, we have some situations with this instantiation, since uh, if you want to follow this approach, you have to make sure that your singleton is light. I mean, it doesn't consume a lot of memory, because there are some situations that you need your singleton object to be instantiated whenever it's needed, right? Sometimes in your project lifecycle, there might be moments you do not the singleton object, and if you follow this eager instantiation, you will just have, let's see, unused variable within the life cycle of your project, and you're just, let's say, uh, spending memory for nothing. So this is not the best solution for all cases, right? So even eager instantiation. The next solution, um, which is called double-checked locking, which prevents such situations, such as creating more than one instance, and if you want your singleton object to be instantiated only on the moments when you need, you may follow this double-checked locking singleton. So here we have the following keywords, for example, volatile, right? Which makes sure that this, let's say, property accesses only a particular memory, so that you do not have, let's say, duplicates. And also, um, for example, if you look at the get instance method, it's not marked as synchronized, which means several methods can access this method at the same time. And also, object, we have a check here, right? If object is null, uh, even this operator can be also passed by several threads. And the next line we have synchronized here, right? Which blocks singleton class, which makes multiple threads to be executed in a sequence way, right? So here your threads will wait each other, but this happens only one time, only once when your object is known, right? So the first thread will instantiate your singleton, and the next threads will execute this block after the first thread finishes this block. And then you will have, let's say, uh, more efficient solution, since the next time when this singleton is used, it will not your threads will not reach the synchronized blocks, since you will already have this object, singleton object, right? Because in the first time you have already instantiated. So this is double checked locking, which tries to address several um, issues such as multi-threading or creating more than one object in multi-threading, or decreasing the efficiency due to synchronization and so on, right? So this is we can say that this is one of the best solutions if you want to follow, let's say, in Java, in Singleton, where you have multi-threading, and if you also have memory restrictions. So we covered three different ways: classic singleton, synchronized singleton, and also eager instantiation. Uh, you can also implement double-checked locking according to language specifications and according to your needs. So this was about singleton. So do you have any questions about these patterns, singleton or prototype? Okay, I hope everything is clear. Otherwise, you can just interrupt me. And now let's switch to problems. Okay, before starting a problem, let me introduce a context of this problem. So I hope you know this cartoon. So this is basically very old cartoon produced in 1988, and its name is The Land Before Time. So here we have, let's say, a lot of monsters, landscapes, a lot of creatures, right? So we're gonna work on the project similar to this scenes, to this episode, right? So the problem that you will work on is about interactive gaming. So your interactive role-playing game has an hungry appetite for monsters, right? As your heroes make their journey through a dynamically created landscapes. By the way, the landscapes can be any landscape. I mean, it might be sea, you can make air landscape, or just the earth landscape, or some another type of landscape, uh, and uh, and your heroes may encounter an endless chain of enemies that must be subdued, right? So they have to overcome the challenges. So you would like your monsters characters to evolve with the changing landscape. So you might have a lot of combinations of abilities of monsters, right? So it doesn't make a lot of sense for bird-like monsters to follow your characters into underseas creatures. So it means that uh, according to your landscape type, your monsters should have the appropriate characteristics, right? That it means that mm, probably your bird monsters should be on the air landscape, or your shark or your fish monsters probably should live or should be in the sea landscape. And also you should allow your players to create their own custom monsters. So your task is to apply any creational design pattern. You may apply more than one creational pattern, and your task is draw a UML. So I hope that the task is clear. Uh, so uh, It's not your graded assignment. I will announce the graded assignment in the Moodle. And So this is assignment. If you solve and if you show your work, you can earn bonus points. By the way, your bonus points and um, your attendance marks are on the Moodle. If you check your Moodle, for example, yes, if you check your Moodle, here we have. I put a link to your attendance and points. Here you can see attendance and bonus points and detailed, let's say, description for each of the lab about your attendance and bonus points. So if I forget something about your attendance or bonus points, you can reach me back by email and I will reconsider your case. So, mm so Jamil is asking uh, to, it's about, I didn't understand your question to be honest, you, yeah, so the, this problem is your own lab assignment. I mean, it's not graded. If you if you work on this assignment, you will earn bonus points, okay? And your assignment grades will be announced by Moodle, okay? And I will put a description. I hope it will be clear for you. If everything is clear, I hope I answered your question. So if everything is clear, please start working on this problem, on this assignment. I will ask after about 15 or 20 minutes, okay? If you finish earlier, so please let me know.
Sorry, may I ask one organizational question about the assignments?
Yes.
When will they be, and how long time will we have for them? When will they start? Because it's approximately the mid
Yeah.
now, and we still have none of 4 assignments.
So first of all, you will have three homeworks, okay? So you will have
In
three.
according to the model, there should be 4 of them. Like as far as I remember, 3 group assignments and 1 individual, which is graded a bit more than others. Or the
Yes.
grading system is changed.
Individual assignment is performed during the lab. Okay, so
Uh-huh.
we will have uh, assignment, something like this, probably during the lab, where you have to solve in a particular time period. You have to submit your solution. This will be your individual assignment, and you will have three homeworks starting from today. The first one starts today, and you will have a week, for example, for the first one. And I hope that these three assignments, uh, the deadlines for them will not be too strict for you because it's 1 week each of them. Okay,
Okay, thank you.
you're welcome. So, guys, please start working on the assignment, on this assignment. So, if you have questions, please ask. Okay, then I will stop sharing and I will not disturb you. So guys, if anyone ready, I hope the time was enough to draw something. Okay, we have a few people left here.
Can I show you
Yeah, please.
my work? Actually, it is not done, but I just want
No,
your comments.
okay.
Uh, 1 second. Can you see
Yes,
anything?
yes, I can see that.
Okay, so here it is. Mm, I tried to make a singleton pattern in player. So in game we want to have only one player, for example, one instance.
Mhm.
So that is why I decided that method construction method will be private. When we want to get player, we just get player. If it is null, we will create player, I guess. So mm, also I was thinking about factory pattern, um, but
Okay.
I'm not sure.
Okay, so you can implement factory pattern easily here. For example, your landscape can be
Yes,
extended into sea, into, I don't know, land or air, right? So
yes,
you can connect them to, let's say, enemies. For example, a sea landscape can be connected to sea enemy. Ah, yes, you have connected.
yes, yes.
Yes. So
I'm
then,
not sure about arrows actually. Like, if I just want to, am I correct? But I will use turn delegate.
uh, you will use just association, which, I mean, you will use, okay, sea enemy is in C, then it is, as I remember, composition. So
So I just need to uh, avoid arrows if I want to make association. Yes,
yes, so
just
uh,
line between
not
C and C enemy. Or what should I do?
composition is diamond, if you remember diamond.
Okay, okay, but mm,
Uh, but it doesn't. Okay, yes. So if we want to follow UML rules,
no, it is like this should be.
well, this is also arrow. Uh, uh, Composition is black. I mean, folded.
Okay.
If you remember,
Mm-hmm.
we have
Okay.
no another. Can you choose another?
Yes, I'm trying.
Yeah, let's make it. So not this one, not this one.
Not
Let's
this
only,
one.
so not no. Yeah, below, scroll down. Okay. I will show you the link to the uh
Okay.
to the composition application.
Diamond. Oh,
Yeah, diamond.
I'm
Yes.
sorry. I
That's fine.
understood.
So C enemy
But
can
uh,
be
uh,
only in C. Yes.
but actually. Like C enemy can't live without C, so diamond should be in C. Yes, like
You no, C only C. C is using C enemy, right?
yes.
So the arrow, I mean the diamond should be from C to C enemy. So this is correct.
Oh, okay.
So when you work in your home assignments, you have to follow these associations correctly.
Mhm.
This is, we can consider this as factory pattern, right? Since we have different types, subtypes, and they are kind of connected with each other. And you mentioned that you mentioned about Singleton, right?
Yes, like
Your
we have a player.
your game is Singleton or your player?
No, player.
Ah,
Because we
yes.
want to have only one instance. Like,
Uh-huh. Okay. Okay. If you remember, we talked that I mean, Singleton. When you when you want to have Singleton, it means that you have some reason to have Singleton. Okay, why do you want to make player a Singleton? You have some shared resources or what?
because only we have only one player. Like,
Okay, okay. No, this is fine. I mean, it is your game, so you can imagine
yes.
anything, of course. So, okay, so we can consider that you implemented singleton and factory. Okay, thank you for your solution, Alina. So let me note. Today is 15th of. Okay. What about Alina Bogdanova?
May I answer not now because I'm finishing. I found kind of three patterns and I have finished, not haven't finished the drawing yet at
Okay,
all. Like,
okay, no problem. You can reach us back if you finished. So what about Alisa?
Sorry, I also need 5 more minutes.
Okay. So Kirill?
Okay, I can show something.
Yeah, yeah, please.
Okay, I decided to start from some landscape controller. Probably, I'm not sure if it should be a singleton or not, but I just decided to make it a singleton. Maybe our game can be controlled from multiple other classes, and then it makes sense to have only one like point which controls the current landscape or something like that. So then I have an interface for landscape and a couple of some implementations of the landscape. And basically, the landscape contains some abstract monster factory. Yeah, and the monster factory follows the abstract factory pattern. And underlying it, there are some implementation of that factory, maybe some swimming monster factory or flying monster factory or some just random monster factory. And they are creating some particular monsters which are implementations of the monster interface. So
Uh-huh.
something like that.
So you have yeah, Monster Factory, and your landscape yeah, can also be extended into sea landscape and basic landscape. Uh-huh. Okay, so I got it. So swimming monster factory, swimming monster. Uh-huh. I see. I you I think you can also uh, connect monsters into appropriate landscapes, I think, right? Swimming monster to sea landscape.
Yeah, probably, but now they're connected like through the factory. So each landscape has associated factory which creates some type of monsters. So just some indirect relationship.
Okay, okay, thank you. Okay, thank you, Kirill, for your solution. And I have also wanted. Okay, you earned 7%, Kirill. I mean 7 points. So this means 7% of lab points. Okay, let's wait for the girls to finish their job.
Let me share the screen and show what have I done. I haven't finished yet, but like I have some kind of questions. Probably I can.
Okay, please.
Okay. Do you see the screen?
Yes.
So I have found like 3 patterns, but I have shown only like 2 of them. The first part is related to decorator pattern, which was covered during the lecture. I was thinking about the monster type and the fact that monsters generally, like the thing which would be probably a lot customizable by the users, is their appearance. And to make this customization more flexible, the decorator pattern can be used. We have the appearance class, which will be kind of overwritten by some other decorators. Wings decorator is an example of such patterns. We override methods draw and attack and have inner like private field with appearance, and we kind of insert the previous appearance, like I don't know, the face decorator or whatever, to this wing decorator, and this way like it's really easy to create different monsters. The second thing which I have found, like, or feel that it should be this way, is some kind of prototype pattern, because monsters are like it should be, of course, some general interface, because it should be called by the game somehow, like draw the monster now. But also we have different types of monsters with some exact appearance. However, for some monsters which are not custom, we have like exact class, I don't know, like flying monster, which would be like presented by the game initially. And for these kind of monsters, we have like special classes which inherit the monster type, and monster type inherit from monster. So generally we call them monsters interface. However, the class realization could simplify this creation. Also, it's pretty clear that the game itself should implement a singleton pattern, because it is one game and the hero is also one, it probably should also implement this pattern. So something like this.
Okay, so you have prototype and decorator pattern implemented, right?
Yes, kind of.
Okay, so about prototype, so monsters can be copied multiple times, right? That's why you want to implement
Yes,
prototype.
yes.
And also monster class. Okay, monster class extends from monster type, right?
Mm-hmm.
Or monster class.
Monster class is more concrete than monster type. Monster type is more abstract, but it has realization of some features. That's why it is a class. It has realization of an appearance, for instance.
Yes, landscape experience. I see. And you will delegate draw monster into appearance.
Draw monster will be related to the appearance, but it would be implemented, I think, in monster type, yes. Like exact implementation, and monster class will just inherit it.
Monster, you mean appearance?
Monster type has appearance.
Yes.
And appearance will be implemented in monster type. While monster class has exact monster type, and this monster class can be can produce many objects. Like.
Okay, so I got it. I got some monster type. Okay, so you can also probably improve. I mean, add landscape types. Landscape. You have monster.
I have, but I haven't shown it because it also will have something like related to the patterns. I'm not sure how to implement it for now.
Yes, you can create landscape, let's say interface and subclasses for landscape. Then you can just connect to.
Initially, I was thinking that to make a landscape not as a class here, but just like a label of type of landscape, and to work with the landscape only in the game class. Like landscape type here. And from landscape type, if these monsters support the landscape which now in the game, then this monster could be put into the game.
Okay, what if your monster can support several landscapes? Like here you have a good logic. I mean, for example, wings decorator, right? Let's imagine a dinosaur which has wings as well as, let's say, legs. So
and we can put the wings inside legs, like with appearance, with this decorator pattern.
Yes.
Like first create legs, then create wings.
Yes.
But I'm not sure that this kind of works in landscape because, like, as I see the game, while we play, we have only like one landscape at a time, or like this movement of the landscape during the time. But the hero is always in one landscape, like in one or another. And when the hero is in the landscape and we should generate the monster, we are generating the monsters who can live in this landscape. And using the landscape types, probably it's just a flag like boolean integer string kind of, or enumerate, which would be the most appropriate. Talking about Java, when we know that the monster supports this type, we can select this monster, and it is generated like monster type or class is selected on random, which monster will be now the next. So that's why I don't want to put landscape inside the monster type, just a label of landscape type.
I see, I see. Yes, yes. I mean, obviously, it's your game. You can handle the logic by your own. Okay, no problem. So as we said earlier, you can improve further, but I see prototype and the creator is implemented here. Okay, thank you, Alina, for your solution. Let me note. Okay, what? Okay, what about Alisa? Have you finished?
Yes, I can show.
Yeah, let's discuss your diagram then.
So can you see my screen?
Yes, sure.
So I implemented just a pattern prototype to clone monsters.
Okay, so it is good that you followed UML notations carefully. So here is prototype. It can be cloned, right? Okay, so we have monster 1 and monster 2. So, monster one can be cloned several times. I mean, in your game,
Yes.
as I see, there might be a lot of monsters. That's why you won't just clone the same monsters, right?
Yes, actually, I guess there can be multiple monsters with the same features. So, like, that's okay to have several copies.
Yes, yes. And you wanted, did you also want to implement other patterns such as I see other classes here, landscape type. These are for monsters.
Yes, yes, yes. Yes, actually, also it's worth to implement pattern decorator as Alina did, but I didn't manage it yet. And I decided that pattern singleton is not applicable in my case because I want several copies, not just one monster.
Yes, but you may have another, let's say, singleton, such as maybe, I don't know,
Player maybe.
let's say store monsters, something like that.
Yeah, maybe yes.
Or yes, which will be instantiated only once. Yes, but prototype pattern, and I see that this is implemented. Thank you for your solution, Alisa. Let me note you as well. Okay, so I think we have discussed all of your diagrams. We have a few people here. I think we can finish our lab. If you have questions, please ask. Otherwise, our lab is over. Thank you for your participation. And I will announce the home assignment soon.
Goodbye.
Bye.
Thank you, goodbye.
Thank you, goodbye.
Bye. Thank you.